Okay, good afternoon, students. I'll be taking you mathematics today, and the topic is set. So we are going to see the definition of set, and we have the definition as what? The collection of well-defined objects. When we say objects, this object can be numbers, can be place, can be alphabet. So, but they should be well defined. When you say set of numbers, then it should be numbers only. And when you say alphabet, it should just be alphabet because it's well defined. So now we have set of numbers, which is A is called a set. And a set is being denoted by what? A capital letter. Then we have the set of numbers, which is 1, 2, 3, 4, 5. So this is a set A, and the set A is what? Numbers. So these numbers, we call them elements. And elements are always denoted by what? Small letters. Why the set is denoted by what? Capital letters. Now, we have the set of colors. B is called set B. Why the element is what? Red, blue, and what? Green. So we call this is the set of what? Colors. So now, and a set, most importantly, you need to know that set is being, we differentiate the next set by using what? Commas. This is what makes this to be what? A set. We use what? Commas to separate each element. This is an element, this is an element, this is an element. So each element must be separated by what? Commas. So now we have types of set. The first one is what? An empty set. Or we call it what? Null what? Set. So any of the names can go with it. So when we say null set or an empty set, this is where a set that doesn't have any element in it means I can have set A with no element in that set. So now if I have a coiling bracket, there will be no anything in the coiling bracket. So we call it what? An empty set. Now we have a singleton set, means the element in that coiling, for it to be singleton, it should just be one element. It can be what? One in a single coil bracket means like now example I can have only red, then I'll close the coil bracket. So it means that element is just one, and we call it what? A singleton set from the word single. Then we have the universal set. We call it in mathematics as the mother of the set. When we say mother, all the elements are contained in that set. And that's why we call it mother. Means other sets can be found in the universal set. Then we're going to see example of it when we come to see more example, we see universal set. Then we have equal set. The equal set definition says that all the elements, if I have two sets, A and B, for it to be equal, they must have the same number of elements. Means if set A has 4 elements, means set B must also have the same element. What I mean is that if set A is A, B, C, D, then set B must also be what? A, B, C, D. The element must be the same. Means I can have B, A, C, D. As far the elements can be found in A and also can be found in B, then we say that elements are what? Equal. But when we say equivalent set, we say if the equivalent set, the elements of A will not be the same as B. What I mean that if we have A, B, C, D, 4 elements, then I can have an equivalent set as 1, 2, 3, 4. Means I have 4 elements in A, but I have 1, 2, 3, 4 in B. But all we know that they have what? Four what? Elements. That's why we say an equivalent set cannot be what? An equal set. Because in the equal set, the element in A must be the same with B. But why equivalent set, they are saying that the number of the elements should just be what? The same. So that's the difference between the equal set and the equivalent set. Then we'll come to what? Union of sets. When we say union of set, means when you combine a particular set with another set, then you combine them together. Just like example at home, your mom came from a different family, your dad came from a different family, and they came together and become what? A particular family. They form their own family. So we call this type of set a what? A union set, because all of them came from different background. An Ijaw man can marry an Igbo woman, and they form what? A set. This is example one of union of a set. So now we have intersection of set. Intersection of set is where a set from A, you can find a set, an element in A, and also find it in B. Like now, example, if I say 1, 2, 3, 4, then I say 2, 3, means I have 2 and 3 in set A, and I can find it in B, 2, 3, 4. I can find 2 and 3 in set B, means you find the intersection of that set. When we say intersection, what can you find in the first set that you can also find it in the second set? We are going to see example of intersection set. Then we have complement. Complement of set means elements that can be found in the universal set, but they are not found in a particular set. What it means that you can find a particular numbers or elements in the universal set, but when you come to a particular set, you cannot find them. Then we call that set, that element as what? Complement of a set. So now let's see what is a universal set. Okay, we have two examples. So now we are going to start with the first one. This is called the universal set. It contains everybody in the universal set. It takes everybody. So now we have set A. Set A has Ada, Olu, Apos. While set C has Ejiro, Apos, Inua. So now they say union. When we say union, it means you combine the set A and C. It gives you the union. So now the union is we have Ada. So we are going to take their first letters. We have Ada, comma, we have Olu, comma, we have what? Apos, comma, then we have Ejiro, comma. Apos is appearing twice, so we just pick one of the Apos. Then we have Ulua. Ulua. Okay, I have to clean it so that I'll put the names in full. Because if you check, there's A here. A, somebody will get confused. So now the first one, when we say union, we combine the union, means we combine S, letter S and letter C. So the first one in letter X, we have what? Letter S, we have what? Ada, comma, what? Olu, comma, Apos, comma. Remember to put comma. That's what makes it to be a set. So we have Ejiro, comma, Apos has already, we have written Apos, so no need to write this again. So we'll go to what? Inuwa. So this is called the union of what? Set S and set C. Now, let's go for intersection. Intersection means the element that you can see here and also is repeated here. You see, we have Ada here, we don't have it here. We have Olu here, we don't have it here. But I have Apos. I have Apos. So one of the first intersection is what? Apos. Now, I have Ejiro, I don't have Ejiro here. I have Inuwa, I don't have Inuwa. So the intersection is what? Apos. This is called the intersection. Intersection of set S, intersection C. Set C. So now, what about this? We call it what? Complement. Complement means we are looking for the set S complement. When we say complement, this is set X on its own. So for me to find the complement of S means the names that are found in the universal set, but we cannot find them here in set S. So now, look up. I have Ada here in the universal set, is appearing here. I have Olu here, is appearing in set S from the universal set. I have Apos here, is also in set S, but I don't have Ejiro in set S. I don't have Inua. So the complement of S is Ejiro and what? Inua. So now I'll have Ejiro as a complement of S, and I will have what? Inua as a what? Complement of S. Means if you check Ejiro and Inua are not in this place. So now if I want to take the complement of C, then I'll still go back to the universal set. Complement is always gotten from the universal set, not in anywhere. So now I have Ejiro, there's Ejiro, Then I have a pause. There's a pause in one. So what I cannot find in C is what? Aja. Aja is a complement to C. Olu is a complement to set C. And what? I think that's the only two things that are complement. We have Ada, no Ada. Olu, no Olu here. Apos, we have Apos. Ejiro, we have Ejiro, and Ana. So these are called the complement of C. The idea of the first example will also apply it here. So now, they say the universal set are set of numbers from 1 to 10. That's the mother of the set. So now we have set P. Set P is gotten from the universal set 1, 2, 4, 6, 10. Then set Q is gotten from the universal set 2, 3, 6, and what? 9. Now they say show that P union Q complement is the same thing as what? P, Q complement. P complement intersection Q complement. Now, let's check. Now, I'll put it as, I'll take this to be what? My left-hand side is equals to what? My right-hand side. So now, let's solve the left-hand side first. So now, I have P, U, Q complement. First, you solve what is inside the bracket according to BODMAS. The bracket first. So now I have P union Q. From the idea, we say that you combine the two, the union, P and Q. The first element I can find between set P and Q is what? 1, 2, 2. You pick one of the elements, 2. I have 3, no 3, so I will pick 3. The next element is what? 4. The next element is what? 6. The next element is what? 9. The next element is what? 10. So it means we have combined this element to give us what? Union of what? Set P union Q. So now, this is the P union Q. So now we look for the what? Complement. You will look for the U. This is U union. So now we take the complement. The complement means elements that are in the universal set, but they are not here. You cannot see them here. So now let's go together, students. We have 1. 1 from the universal set. We have 1. So it's not a what? Complement to us. We have 2. We have 2. It's not a complement. So now we have what? 3. 3. It's not a complement. We have what? 4. 4. It's not a complement. I have 5 in the universal set, but I cannot find 5 here. So this is a complement. Then I have 6. 6. It's not a complement. I have 7, but no 7. This is a complement. Then I have what? 8. No 8 here. So it's also what? A complement. I have 9. There's 9. 10, 10. So now, the complement of P union Q is given as what? 5, 7, 8. Now we have solved the left-hand side. Now let's go for the right-hand side. We have what? P intersection Q, Q complement. P complement intersection Q. So now, first, we are going to solve what? P intersection what? Let's solve for P complement. First, what is P complement? The P complement means elements that are in the universal set, but you cannot find it in P. 1, 1, 2, 2. I cannot get 3 here. No 3 in P. 4, 5. There's no 5 in P. 6, 7. Cannot find 7 in P. I cannot still find 8. No 8. No 9. But both of them have 10. Means check P, there's no 3, no 5, no 7, no 8, no 9. So now let's take Q complement. Elements that are in the universal set, but we cannot find them in Q. There's 1 in the universal set, no 1 in set. We have 1, 2, we have 3, no 4 here. no 5, but we can get them in the universal set. 6, there is 6 here, so we are not taking it. 7, there's no 7 here. 8 in the universal set, but no 8 in set Q. Then we have 9 and what? We don't have 10. We have 10 in the universal set, but we don't have 10 here. So now we have gotten this. So now P intersection Q is equals to, now find intersection. What it means, what can I see here? I can also see here. That's what they're saying. So now I have one, no one here, so it's not an intersection. There's 3, no 3. 5, 5. So the intersection, the first element is what? 5. The second one I have 7. There's 7 here. So it's also an intersection. Then I have 8. There's 8. It's also what? An intersection. I have 9. No 9. There's 10. So the intersection of what? This is given and this. So now they say that the left hand side is the same thing as what? The right hand side. So it's equals to P intersection Q. So what do we get for the answer of this? The answer is what? 5. Let's open it. 5. This is 5, 7, 8. Let's see. Is it the same thing as the answer for this? Which is what? 5, 7, 8. So now I have 5 here. There's 5, 7, 7, 8, 8. So means it's correct that this P union Q complement is the same thing as P complement intersection Q complement. Class. Student, this is your assignment. Try and submit on the comment section.